Hi students, welcome to this course, PLC Automation, an introduction to programmable logic controller. I am Professor Yao. BCD or multi-bit data processing. The keywords: the input and output devices, the input and output modules, the output indicator, 7-segment display. BCD data is handled like analog data. Figure 22.9 shows a block diagram of how BCD devices and the data are used by the PLC. The input and output devices are mathematically matched directly by the input and output modules. No conversion of values is required because the input and output devices are built to match the module directly. In this illustration, the input number is entered directly from some wheels. The input data is scaled to half for the output indicator. The resulting half value is sent to the output devices, a 4-digit 7-segment display. Since the CPU does math in binary, appropriate BCD and binary conversion are carried out as shown. The illustration in figure 22.9 shows multiplying by 0.5. Alternatively, you could divide by 2 and obtain the same result. This picture shows the BCD or multi-bit input and output system. PLC analog output application examples. The keywords: analog in or discrete out, analog in or analog or BCD out, 2 analogs in or 2 analog out. PLC analog output application examples. This section presents 6 examples, 4 of which have multiple inputs or outputs as representative of analog PLC operation. These examples are example 22.1 analog in, discrete output. Example 22.2 BCD in and discrete out. Example 3 analog in, analog or BCD out. Number 4 BCD in and a BCD or analog out. Example 5 2 analog in, 2 analog out. Example 6 2 BCD in and 2 analog out. Example 1, analog in and discrete out. The keywords, analog in and discrete out, greater than and less than, amperage, ampere, comparison function, analog in and discrete out. The example given in figure 22.7 was analog in and discrete out. This figure's values further illustrate the example. The problem is to have one output go on when a certain level, 0.5 ampere, is reached, and another output on when the amperage is between 0.8 and 1.1 ampere. To accomplish this, use the input values with comparison functions. For the first input, use the GE function, since the second condition has two limits. One needs two comparison function, in this case, greater than or less than. 22.10 illustrates how a program, the PLC, accomplish and the required comparison and energize appropriate output. This picture shows analog in and discrete out. Example 2, BCD in and discrete out. The keywords, BCD somewhere, the comparison functions, BCD comparison problem, PLC programming. A problem similar to example 1 is illustrated in figure 22.11. The input is the BCD somewhere that counts up to 9,999. If the input is 3,750 or above, output 6 is to go on. If the input is between 6,200 and 8,542, output 7 is to go on. Assume that the input data is received in register, input register number 6 in the CPU. As stated previously, the CPU works in binary. Therefore, you must first convert the input register number 6 value to binary. Holding register number 45 will receive the converted value. Thereafter, the comparison functions are the same as in example 1. Figure 22.11 shows the PLC programming for this BCD comparison problem. This picture shows example 2, BCD in and the discrete out. Homework. Handwriting all keywords and submitting them to Coach Facebook. Just do the online quiz and see you next time.